Hello, I'm Prakhar, and today I'll be showcasing Pharmetrix. Pharmetrix is an intelligent pharmaceutical control system that combines pharmaceutical inventory management, point of sale, cold chain monitoring, and secure edge deployment into a single architectural platform. This project started with a simple observation. Traditional pharmacy software treats medicine like retail products. But medicine are not just retail products. They are batch sensitive, they are expiration bound, they are temperature critical, and they are regulated, very much regulated. And if it were to be a small mistake in the inventory management, then it can become the game of life and death for a patient. Uh, to give a personal example, my mother uses a temperature sensitive injection. If it remains at room temperature for more than an hour, it becomes unusable. That injection alone itself costs about 4,000 rupees per dose. So when people invest that kind of money into medication, the system managing it must enforce discipline, must enforce compliance. It should not rely on human memory or loose management. It should be a disciplined system. Pharmetrix was built to enforce pharmaceutical correctness at the architectural level. When we come to the core problem, most pharmaceutical point of sale systems track product quantity but not independent batches. Do not truly enforces first expire, first out. They have weak traceability and they treat cold chain as a completely separate system. So cold chain applications log temperature and sends alerts, but they do not integrate with inventory states. Okay, so if a pharmacy is doing cold chain monitoring, that would be completely separate from the inventory. So there is no relation between temperature violations and inventory management. So at this time, we are doing the only thing which is we are unifying them together. Okay, so Pharmetrix unifies them. What Pharmetrix does, at its core, Pharmetrix integrates four layers. It integrates cloud-based inventory and point of sale. It integrates batch-level pharmaceutical control. It integrates Raspberry Pi based edge devices and cold chain monitoring linked to device identity. The device being Raspberry Pi. So the inventory and POS works in the way that I'm going to describe right now. So Pharmetrix separates medicines and batches into independent data structures. A single medicine can have multiple batches and each batch is tracked independently. Inventory is batch linked. When transactions occur, the system enforces first expire, first out. At transaction time, it performs atomic quantity reconciliation. It supports individual unit sales, such as selling 10 tablets from a 15 tablet strip. Like we usually get limited amount of tablets. For example, if you have prescription from a doctor that requires only 7-day medication, and the medication comes in a pack of, for example, 30 days. You don't need that much. So we allow our users to get medication based on how much ever quantity they want. It prevents expired stocks from being dispensed, first of all, and then it includes transaction rollback protection. How does it do that? We have internal states that require a transaction to be completed, so it cannot be rolled back. There is no rollback state for a transaction. If a transaction is initiated, it will be finished. So these checks are not optional, they are enforced at the architectural level. Now it comes to standard mode versus advanced mode. Pharmetrix operates in two architectural models. The first being standard mode. Standard mode is cloud centric. So if you're not willing to invest money on hardware, this is the one for you. Standard mode is cloud centric. It gives you inventory and point of sale logic that executes on the cloud server. Data is being stored on the cloud cluster, and Raspberry Pi is very much optional. It does not need integrating, and you can work perfectly without it. It's a simpler deployment. It's suitable for small environments, and if you are not willing to invest money in it. This mode is completely functional at this point. And when it comes to the advanced mode introduces distributed execution. It brings in the Raspberry Pi. It becomes the primary compute unit for inventory logic. So all the expiration based logic, all the temperature violations, everything will be computed on the Raspberry Pi itself. We are not using cloud backends for that. We are using the Raspberry Pi itself to compute every single batch logic on device locally, and that first of all gives you data compliance, because your data is safe with you on your local device. So we are not collecting data from the user as well. And secondary, the user data that will be collected can always be queried from the local device, and we can bifurcate the user data collection based on requirement. So user can create an account that will be on the cloud cluster, obviously, because that needs to be managed via cloud. But all the inventory data that will be inside the Raspberry Pi, so it will call Raspberry Pi. So that is an optional model. We do allow data to be stored on the cloud cluster as well with the Raspberry Pi, but still the computation will still be happening on the Raspberry Pi. So the process will be something like this. The Raspberry Pi becomes the primary computer unit for inventory logic. After that, the cloud sends a request to the edge. The edge processes the inventory decisions locally, and edge to cloud consistency violations ensure synchronization. So the consistency we are talking about right now is basically the sync between the cloud and the edge, and that is being achieved by first of all cloud cluster, which is connected with the both cloud backend and the local cluster itself. And then we have consistency based algorithm, which provides every single transaction will be queued, and until unless that transaction has been executed properly, it won't let any read or write operation happen till that point. So it will be basically working as a control layer for any kind of sensitive operation if multiple transactions are underway. So after that, this overall everything that I've talked to you about, this allows faster anomaly detection, because since the data will be local, and Raspberry Pi can catch any random anomaly that happens, it can quarantine the medication immediately and won't allow you to sell it. It reduces cloud dependency, as I talked to you earlier. It allows users to be local resilient. So every single data, since it's local, and every alert generation is local, so everything will be local resilient. And then it's a controlled distributed architecture. So everything is under the control of the user regarding their own organization, and the hybrid architecture allows every single type of user to exist peacefully in their own tier. So advanced mode decisions are not manually chosen, they are enforced by architecture. Now we come to the secure pairing, because I have talked to you about Raspberry Pis and I have not explained how the pairing system works. So let's talk about how the cloud and Raspberry Pi connect. After the Raspberry Pi is initiated, it generates metadata like MAC address, tailscale IP, and device ID. This metadata is displayed over the local Pi dashboard. A technician enters the metadata into the cloud pairing model. Only an organization admin can complete the pairing because we wanted limited access to the device metadata specifically, and the device pairing, because we don't want anyone to revoke the device by mistake or manipulate the device in any way possible. So the device pairing and onboarding system is only limited to organization admin. And if I were to just show you quickly how the device pairing flow will look, then I can just show you. This is the Pharmetrix website, and let me just get on this quickly. We can just quickly go to the dashboard. This is the dashboard, and we can see it's loading. It's running completely on the cloud right now. So this is the current overview of the dashboard. It's still in development. This is just the beta version of this, and we don't want this to be the final version. We are improving on it as well. So let's go to the devices page, and we can see that I have one device connected right now. It's showing up as online because now it's online because it was showing up as offline, because the thing is we are only polling the Pi at the state when it's available. Like, we are not constantly polling the Pi, because first of all that will defeat the purpose of it being an edge device. So the Pi is only polling when the user asks for it. So right now, like I opened this page up. Now the Pi is online. Before that it was offline, but the local polling was running at that point. Okay, so let me show you the current metadata of this thing. Okay, so right now we can see the device ID, current status, location, any queued commands and all that. It's all there. And when we come to pair a device, this is the pairing modal. You can see we can enter device ID from the device itself, like the metadata that I talked to you about, the serial number, the device version you can set according to you. We have various connection methods. We are primarily using tailscale and public IP, but tailscale is the primary connection method as of the version 2 of pairing system. So we are using tailscale. You can name the device. You can give the last known IP as well, just as a backup method. Then we have the MAC address. We have the heartbeat interval for understanding to just being in a constant connection with the Pi itself. Then we have the tailscale IP. That is the primary source of connection to the Pi, and the location is also optional. So when we this is the organization pairing code. This organization pairing code is unique to every single organization. For this organization, it's 1 2 3 4 5 6. And for other people who will create a new organization, this code will be generated on random. It will be a 6-digit code that they can use and pair their devices. So this was basically how the device pairing workflow goes. And after the devices, the metadata is entered and the device pairs, the device will poll for status. It will store credentials properly in between the first pairing and the temperature flow, the reading flow. In between that, it will store credentials properly. It will transition into active state. When it's in the active state, there are no bypass routes, no automatic self-registration, no approval chains. It's approved, and after that the pairing is controlled, it's secure, and it's only auditable by the admin. After that, when the device is in the active state, every single request coming to the Pi cannot be bypassed. It will be on the Pi, and it will go through a secure API security architecture that I'm going to talk to you about right now. So the security architecture is basically, it's a 4-layer security architecture. Every single API call must pass these 4 points. The 4 points being, first of all, it will validate the user. If I am a user, I should belong to the database itself. Like, I should be in the database to make a query. If I'm not in the database, my query will be rejected, obviously. After that, it will validate the organization ID and also attached to the request itself. So I am requesting from an organization, obviously, because otherwise I won't be able to be a user in the that can do any kind of operations. So for me being a user, I need to have an organization ID. It will validate that organization itself. Then it will verify if I am a user of that organization or not. And then it will verify if I am the user of that organization that belongs to a particular role that the operation is being performed of. So if let's say device pairing, that can only be done by admin, so it will validate me, then it will validate the organization, then it will validate me, if me being the user of that organization, then it will validate if I am the user of that organization as an admin, and do I have the rights to do any kind of operation on this organization or not. After that, that request will be allowed to go through. No API can bypass this middleware. If any layer fails, the request will fail, and this ensures proper safety and compliance to the overall inventory flow. And after that, when we talk about overall architecture in the tech stack, the edge layer runs on a Node.js backend. It also has some Rust-based utilities for sensor interaction and a React-based local Pi dashboard. The sensor architecture is very simple. It's based on 2 independent 1-wire buses. In standard accuracy mode, there will be cold sensor on one bus and ambient sensors on another bus. In redundancy mode, one cold sensor and one ambient sensor per bus times two buses. So accuracy and versus redundancy can be chosen based on the deployment needs and the user's willing. After that comes the camera streaming. The camera captures raw H.264 frames. It breaks them into JPEG chunks and streams them via MJPEG over HTTP. It's currently functional, and the future roadmap includes computer vision, barcode-based inventory verification, and local model support for hardware acceleration. Right now, we are using Raspberry Pi 4 Model B with 4 gigabytes of RAM, which limits local AI capabilities. The roadmap includes hardware upgrades for proper device interface, but right now we are managing with this base setup. And let me just quickly go ahead and give you a quick tour of how the sensor streaming and camera streaming works. So let's go back to the Pharmetrix app really quickly, and we can go to sensors. Okay, so right now we'll see that Raspberry Pi is there. It's currently showing as offline, but that is expected behavior because the Pi stops polling after a certain time. Now we can see this temperature, the 3.13 degrees centigrade, this temperature is coming inside of the refrigerator, and the 25.94 degrees centigrade is coming from the ambient. So I have currently named these sensors their sensor ID, but these are renamable at the time of configuration of the device because they are set and go type things. So you can just set one sensor as ambient, and that will remain as ambient. It completely depends on the deployment. So right now we have just named them IDs, but they can be named whatever. And when it comes to the camera stream, this is a really good thing in this project. Now it's showing up as online. There are some minor UI tweaks that are still needed. So it will show me sitting here right now. Just give it a minute to start because it's still a little sloppy on some ends. It's still in progress. We are still refining it. So you can see right now I am sitting there. There is a certain lag right now because it's all over the internet, and the processing and takes a bit of a time. But if I just go ahead and wave to it, you'll be able to see me in a while. But it is completely functional, and when it's operating under really good internet conditions, we can get up to 60 frames per second with about 720p resolution. But right now we are not getting that much because of the limited hardware and as well as limited internet capabilities. Other than that, everything else is functional. We now know that the hardware is functional. We also know that how the entire workflow is going on. So we do have some custom algorithms in place. Pharmetrix includes internally designed logic for intelligent first expire first out batch selection, conflict safe quantity reconciliation. We by that basically is we mean that when we have varying quantity in this individual sales mode, we can resolve those quantity conflicts easily without having any kind of issues. And then we have expiration based distancing resolution. That is basically what it says. We won't allow any kind of medicine to be dispensed if it's conflicting with the expiry date. And then we have transaction rollback protection that I talked to you about earlier. And at the end, we have edge to cloud consistency validation that I also talked to you about earlier. It's pre-built in the pairing system. The internal structure right now is currently under a provisional patent process. So the implementation details are not publicly disclosed at this time. But the current status is standard mode is perfectly functional. The sales workflow is operational. The pairing system is complete with some minor additions pending. Sensor stream and camera streaming are functional, and the edge cloud architecture is active right now. So it's a working system, not a conceptual prototype at this point, but there are some major requirements that we need to fulfill at this point. Our vision is to not just build an app, it is to build an infrastructure. A long term goal is a pharmaceutical aware operational layer with unified cold chain and inventory control, multi-organizational scalability. Like we want multiple organizations to be using this under our deployment, and we just want compliance to be brought in every single place. And we really do want in the long term the deployment for the retail pharmacies to hospital networks and everything. We want to cover up basically everything in the long term. So Pharmetrix enforces correctness through architecture, not through user behavior, as I talked to you about earlier. That is our core philosophy behind the system. And if I were just to give you a quick rundown of the entire thing, so let me just give you a rundown of the pairing system and all. Sorry, not the pairing system, the inventory management and workflow. So this is the dashboard, and it will just take a second to load. Yeah, this is the dashboard. We can see the recent sales here. So we have the total medicine count. We have the today's sales analytics. Then we have at risk and quarantined. So any medicine which is expiring nearby and is quarantined will show up here. There are a few bugs here and there that sometimes the expiration count does not work, but that is currently under development and currently under repair work and bug patching and all. But other than that, overall it's functional properly. So let me just give you a basic rundown of what the inventory page looks like. This is the inventory page. We can see multiple medicines being here. They are also quarantined based on expiration and can be quarantined manually. And if we were to go and create a sale, so this is the really important part that I talked to you about earlier. Creating a sale is a it's completely dependent on how you want to do it. So creating a sale is either you can create a quick sale or a build sale. So as it says, quick sale is a fast checkout without customer details. So let's quickly create a quick sale. Okay, so when we create a quick sale, it asks for barcode. Okay, right now I don't have a barcode scanner, so I'm going to enter the barcode manually. And just press enter. It will fetch the medication detail. It will show you the medication detail for verification, and then we just press enter. It will ask for quantity. Now the quantity is the key role player here. Like we have the sales unit. So for the sales unit, we can either select package or individual. So by individual, we are basically meaning individual tablets for sale. Like we get 7 tablets or 10 tablets, whatever we need. Or we can get individual packages like 10 strips, 20 strips, 1 strip individually, whatever you want, all possible. So let's do two tablets. Okay, people sometimes buy 2 tablets, right? So let's do with 2 tablets. So it's gonna cost us 4 rupees, and the unit price is 2 rupees. The sales mode is quick, and we are paying by cash. We are trying to implement a Razorpay in the future. In the actual deployment, Razorpay will be implemented as a merchant payment processor, and when we complete the sale will be completed, and we can go back home and we can see 4 rupees sale will be displaying over here. So just give it a second. Yeah, we can see that today's sale has gone up to 4 rupees, and we have a 4 rupee sale for a walk-in customer. So the customer name won't be generated, but it will come up as walk-in. Now we do the build sale thing. It's really good, and let me just show you. We are going to go with the same medication, and we can go next. And right now, last time we selected an individual quantity. Now this time we'll select packaged quantity. Let's go with 3 packages. Okay, we'll go with next. The customer details I'll auto populate, and then let's just go next. And okay, the amount is coming up to 60 rupees, unit price being 20 rupees, and let's complete the sale with cash. And in the build mode, we will get a proper bill to print. This will be printed by the individual pharmacy's printer. Easily, you just have to click enter. Right now I don't have a printer attached, so it's only asking for a PDF, but that can be easily resolved, and you can just look at the bill. It's a basic bill, and it will give you a proper customer detail. It will also give you the bill details and the medicine itself, what medication I'm purchasing, how many, what is the manufacturing, what is the expiration, everything is there. And this is the bill. You can download it, you can print it, whatever you want to do, you can do that. So we are basically providing every single utility with this thing. And yeah, this is Pharmetrix. I would like to thank you all for giving me this opportunity to present you my project, and thank you very much for taking the time to review this video. Thank you very much, and